So this is the this is the particular notebook that we are using right now. And if you remember, like I had bucketed the cells, what all cells are doing what. And first is data loading. So data loading or data ingestion, basically from any data science project, you need the data, right? So data will be coming from different sources. So in our case, it is coming from a public GCS bucket, that is a Google Cloud Storage bucket. That is nothing but similar to Amazon S3 bucket. So that's a blob storage, which is also there in Azure or maybe like in a bucket. So all these are like you just need to, if you are operating in any different cloud provider also, you need to use the wget. So wget is a command where you can like send a request to a URL, and it will give you the response back. So this is also one of the way to download the dataset in a zip format, and then we are unzipping it, so keeping it into a bucket, copying it, and all this sort of thing. So this is nothing but loading the data. Okay, then we import the libraries, then we do the data ingestion. Ingestion means we are loading it into a pandas data frame. So that is our in memory. So we discussed like how the pandas memory, pandas dataset look like. So pandas is a library that is used for data processing in Python. So we are doing very like basic right now operations on pandas, such as the read CSV. Read CSV function is there. So read CSV is accepting a URL. URL is having a bucket name, our CSV. So basically, in the way we have loaded this in the, if like in this command, gsutil cp, that's copy. So gsutil is the utils library from Google for GCP. Okay. So you need to copy the data into the bucket, and bucket name will be again used. So bucket name plus slash our.csv. Basically, we are reading that particular file here. Okay. And then we did a bunch of pre-processing, like filtering the columns, you know and then we are splitting train test. So we had discussed why we are doing that, and we can compare which, how much train, how much test, and how much validation we need. So this is that you can choose your own, and then specifically it will particularly do the splitting. Okay. And finally we are keeping the X train and Y train. So can someone tell me the difference between X train and Y train? What do we keep in X train?
Maybe white train for result, X train kind of input or
Correct,
dependent.
correct. Absolutely right. Yeah. So in the other language, we can call dependent and independent. So dependent is the one which is dependent on other things, and independent is one which is like not dependent on anything. So X train is like an independent variable, and Y train is dependent, because we need X in terms of finding a Y. That's why. So that's absolutely right. So then we saw like model metrics, which model, like how to compare two or three different models, and like how to understand the performance. So we have adjusted R square, MAE, mean absolute error, MAP. Basically, mean absolute error is nothing but like the way you are looking at the error. Say example, if you are predicting 50, but the actual prediction is 49, so the absolute error would be 1. If you're predicting 51 and the actual is like 50 or 49, MAE will be 2. So it's basically either plus or minus. So we'll take an absolute. So similar way, it's MAP but in percentages. MSE is we are squaring the error. So this is to penalize the big numbers, like if there are some. So this will, say example, you have a two difference of 49 and 51. So two will be fine. It will take 4 as a error. If you will have more error, like more difference in the actual and the prediction, this will go higher. So this can penalize very high numbers. So that's why it's having a different significance. Okay. So this is just, we have gone through the basics of this, and in some point of time we'll look at the metrics in more detail. So because this is again, will be given you as a part of business, and all this code like which we have seen, you might not be writing this entirely on your own, but you need to understand what is going on. From here, a work of an MLOps engineer starts. Okay, in the level 0 automation. Okay. can write this. Anybody has any questions so far? We can quickly check with the questions, or maybe like we can go ahead. So from now we'll be working as a like MLOps engineer, and right now this is the work for data scientist that has been done above, and now we have the models. That's a model.pickle file that is shared by the data scientist, or maybe like we know like it is dumped in the bucket, so we'll just copy this in the bucket and see it. Okay, let's start with this. If you have any questions so far, we can do ask the question, and then what we want to see is today is our MLOps. I think we had covered this as well, if I'm not wrong. So in the bucket, like I'm not sure. Have we covered this, or you guys do remember this? I think we stopped in the pipeline part, right? I think we stopped here only, or maybe like how it is. Do you remember? Anyone of you remember like whether we have covered this one? You know this, or like we have any which ways we can quickly cover this. So like this is the manual way of doing it. So say example when you have having a model, so model.pickle file. So someone can help me like what is model.pickle, or maybe why we are doing this. Anyone?
I think
You
we are removing some kind of unwanted columns and then we are putting that and then we are recreating that particular something of that sort.
okay? Um, not really on this one, but this I'll definitely help you with what is this one. So what you mentioned, right? That's a part of a pre-processing. The steps which we covered is a part of a pre-processing. So this is our serialization. So what does serialization stand for? Anyone knows in Python? Object
Uh,
serialization.
it is conversion of Python object into JSON. Like it can be used by another technologies also.
Perfect. Yes, that's one way. Like that's a right way. But yeah, not only limited to JSON, but it's on in any serializable format that can be well accepted by the other, or maybe it preserves the original values, or maybe like form of it. So that's known as a serialization. Thanks for answering that. So serialization is nothing but which helps us preserves the values. So example in our model file, model.pickle, this will have some values like parameter values. So what are these parameters? These are nothing but which are defined by our model. So this is the model, random forest regressor. So this model will have some parameters. If you want to ever go depth and see, so if you see, if you run this model, right, we will be having different parameters. So model dot predict is there, model dot whatever, like model dot n number of trees, or maybe random forest, how depth is that, so depth of the tree, so that particular things will be there. If you see, this is our model. So this is actually a Google Cloud model, so this is not our model. I think we have executed the steps, right? That's why we finally get the model is here. But if I talk about this model, so it's having all these particular things. So like
So this,
in the
yeah, Bhavesh, sorry for interruption. So this random forest regressor, the method, the user-defined method, or the existing Python method, which we
yeah,
can use for the scientists.
yeah, we can talk about. I think if you remember on the first time, we'll see like we are using sklearn. So sklearn is a very popular library which is giving you some in inbuilt algorithms of the for trying it out. So random forest regressor, XGBoost. XGBoost is also given by some other library or many library, many different, like this is there. So we have a linear regression. So sklearn is a popular library to do initial model work. So random forest regressor is again by them. Okay. So you don't need to like actually write the algorithm and all everything by yourself. But yeah, so this is the work of data scientists. They will do like all the like model building. So this is in machine learning and deep learning. So there are two bifurcations to the model building, if you guys know. So machine learning is nothing but where we are using traditional techniques. So this comes under machine learning. So in deep learning, we have neural networks. So neural networks has the all the things, right? So a neural network, you built your own neural network, or maybe you use already pre-built algorithm. So the machine learning field is very matured and it already has a lot of algorithms. So we just reuse it. Yeah.
Got it.
So this is also for your knowledge. It will be really good when you're working in a company and you are having certain interactions with the data scientist and they mention we are using some algorithm. So from which library they are using. So for optimizing that model, you might be able to help them. Okay, what is the library? What how we can. So serialization is one thing that is also known as. I'll introduce one more topic here now. So it is known as quantization. So in the quantization, say like for every so we reduce the size of model. This helps us to get faster inference. So at the background, what is happening? If you see like the parameters, what we are doing, we are just calculating some numbers. What is the prediction? So what is our prediction? Is a calculation of numbers or maybe some operations. So we are doing either multiplication, we are doing addition, say in our regression part, right? So it is y equal to mx plus c. I think we have seen this. So this is nothing but there is a multiplication, there is a addition. These two operations are there, and this can be through multiple dimensions. So 2D, 3D, that way. So we need so at the background it's some mathematics that's happening. So this is all like if we make the size of numbers small, like the calculation will be much more faster. So that's how the thing is. Like say example, if you have so numbers are usually in this floating point. So like 1 point 0.06, something of this kind, it will be there. So when you reduce floating point numbers up till like reduce it to round it off to like 0.5, so it will be 0.6, like this example. So this is our floating point representation. This is what the quantization does. So we need to reduce the number such as the operations will be faster like this. So this is one of the way. Like once you have the pickle file, the next step might be if you want to optimize it. So it might be quantization. So we'll look at this later, but yeah, I just wanted to introduce like something like this is also there, so which you might come across somewhere in your work. So serialization is very important part. We you have the model pickle file. So other than pickle, there are some more libraries, joblib. So this is for again some different thing. And then you have so for different models you have different one. Okay. So in TensorFlow, that's a saved model format. So you this is again stay stored in a protobuf dot pb protobuf. So these are all formats, like you have some dot mp3 dot files something. This is also dot, like these files, these are again created by certain library. So this is again created by TensorFlow. Joblab is created by some other thing. So this is used in our sklearn. And also this is a Python default serialization. Okay, so by default, if you use in Python serialization, it will be using this one. So this is a by default option. This is again, you can use for XGBoost. This is our one of the other library models. Okay, so this way you have different number of these things. For TensorFlow, we have saved model. Like this, we will just, so not, it's nothing but serialization. What we summarize, if we summarize serialization, it is writing the parameters in a file. We need to persist the model in memory or maybe storage. We need to persist it in our storage. So basically, these, what a model is, it's a bunch of parameters. So if you say like this model, right, this now, like right now model equal to random forest, this is allocated in our RAM, in our memory. So after this we need to write it into a storage, right? So storage, we need to write it here, dot slash model pickle, and then we'll put this wb is a write binary file, and then model, we need to put it into a file. That's we need, the name is model.pickle. So if we see somewhere here, we might have we might have the model, say example model.pickle. So this was like on 5 days back. If you see, like details, we can see the detail. I think it's not there. Okay, so we can see, if you want to open this with the editor as well, you won't see it. It will be like UTF encoded format, so you might not able to read. This is not a text file or something. So, but yeah, if you want to download it, it's around 70 MB file, which will be like having all the required information. So, what is the step? Like after serialization, so we need to pair a serving container. So we have the model ready. Basically, you have the model binary ready. This is what we call a model binary. So we have this ready. So we copy it into a model path. Model path is nothing but this is our bucket name. So where the bucket location is there. If you write it, you will see here.
Yeah, Bhavesh, 1 minute. So, like, I'm trying to understand model pickle file. Let's say whatever code they develop, data scientist developed, it is generated pickle file, kind of YAML configuration file in Azure that we are talking, right? Like that, it's a kind of deployment file. What it means, pickle contains what? Model pickle, I know, but what does it mean exactly? Whatever you're saying, I'm getting, but what it contains. So who is giving that pickle file?
Correct, correct. So data scientist is the one who is writing this pickle file, or maybe you can be the one who can create. Say example, data scientist gave you a notebook. So he'll say, okay, I have worked in this particular notebook, and in the notebook, until here things will be there, until this cell. So he'll give you, and then you will have to write this particular code. No, that I have the model, you will have to run everything, and that this is so. Usually this does not happen. Like a data scientist also know all of this thing, so they will write this particular thing and in a bucket. So in our job as well, we see like there is a bucket models, like in a original bucket there will be some folder. So in that folder you will be dumping that model, and in the versioning you can also keep the versions as well. Like in the same Google Cloud bucket you will have different versions. So that is what they provide. Okay, along with that they also give you one serving container. That is what we were talking next. Yeah, but if you have any questions, like we can
Yeah,
discuss.
yeah. So like I'm trying to understand. Let's say I have a notebook. How can I convert into pickle file? Let's say we have, that is important, right? Let's say we have a notebook file. The notebook is ready. So we want to convert into pickle file that notebook, if you want to deploy it.
No, no, no. The entire notebook will not be deployed as a pickle file. Pickle is only about the model, the dot model. Okay. So this model, like be it random forest tracer, be it anything, we are talking about this model. So what we are doing is, let's say, let's draw it out. Okay. So we'll say topic as serialization. Okay. So what happens is when a data scientist is, you know, training a model, this can be in random forest, maybe something else, XGBoost. So this is given you in a pickle file, like model. In general, we call it as model binary. So model binary is nothing but some parameters. This can be in normal machine learning language, we call them weights, model weights. So why this is used? It's used to recreate the model. Say right now, you are doing something like, say, imagine you're doing some calculations, or maybe, someone told like in a JSON. So imagine this as a JSON. What does JSON stand for? Then it's only having some, parameters, or maybe like, you are having a dictionary like this in this format, and then there's a key value pair. You know? It's a, like there is a key and there is a corresponding value. Okay. So like this way, we have n number of key value pairs, right? So this only one like that. Like this, many key value pairs are there. So similarly, you can understand that this model binary is similar, having some parameters. So this parameter value will be stored in a something similar format. It is not exactly a JSON, but it's a separate file. That's it. So in the JSON also, you write the JSON into a bucket and then use stuff for the configuration. Someone else gave an example of JSON, so that's why I'm picking up. If you're familiar with this, so this is quite similar. Like we are writing it into a file. So let's say this is our pickle file. Pickle file. This will have maybe arrays. Okay. So this is array. Then array from this we'll say when 0.55. So this can be 1D, or maybe that this can be 2D. Like all these are numbers. Like for you the numbers might not matter, but when you code this in a certain way, numbers will be mattering. Like okay. So we say like this is a 2D. So there, if you have ever delved into machine learning or deep learning, so model parameters has a certain shape. So shape means basically the dimensions. That's it, 1D, 2D, 3D. So like you have for, as I mentioned, for regression, the number of parameters is less. But for some different models, like deep learning models, parameters are like very very high. So deep learning starts with like some 2k, 2000, 3000, 5000 parameters, and then much more, because the numbers are like you are taking time to learn these numbers. Okay. Similarly, like this one, 2, then you have something else. Now you are understanding this, like, so you have some numbers encoded in a certain format, and then you will have this one. So this is your pickle file internally. What you want to preserve is preserve the state. Like you want to preserve the state. That's why you are keeping it into a serialized format, and you want to load back into the memory. Okay. And not only that, this might be only the weights. For example, it might be in this format, weights, but you might also have some other parameters in pickle. So that's not only thing. Like instead, like you will have this one, then you will have some. Say example, you will have n number of leaves. This is one of the parameters in the random forest regressor. So depth of a tree, because random forest is a tree based algorithm. Okay, so that's why we have all these parameters. So for you, you don't need to worry much about the parameters, what we are using, which parameters are there. You just need to worry about, okay, what inside the, what consists in the pickle file. Okay. So we'll see this. If you want, like we can also, look at a pickle file, download it, re-serialize it. We'll do all of everything of that thing in maybe a separate class. I'll note it down and I'll prepare those things accordingly. So, maybe like if you want, I can share you quickly a link here, which can, serialization. I think there is one very good blog that I know. So maybe a data camp is there, few other blogs are there. But one blog that I know is from, one person, Jason Brownlee. So he has written a very good blog. Loading it. Yeah. So this is like, this pickle. Like this is the inspiration. Like how you store pickle for a long time and that does not get affected. Similar is the idea. And here it is saying, what is the serialization? Why do we serialize? Think about storing an integer, how you'd store in a file and transmit it. That's easy. We can just write in a integer into a file. But what about a Python object? So basically, if it's a single string or maybe multiple strings, but we are storing complex Python objects like Python dictionary, pandas data frame, or maybe something else. So everything can be serialized into this. So complex objects as well. And serialization is a process of converting this object and into a format like that can be stored or transmitted. So that's nothing but our this thing. And then there are multiple data types, float 32 for 64 that we have told. Okay, so we cannot ask JSON to remember the data type, but we can ask this thing. So that's why we are not using JSON. And these are some uh, formats that exist. So pickle and HP5, which we have seen, like this is some protobuf, all of these formats that I told, right? So to serialize, they're all different. So this is a example thing. Like he's writing a dictionary, test dict, and then he's writing out into a pickle, and then he's reconstructing it. Basically, using pickle.load. That's what I told you, right? Deserialization or maybe. So you can maybe use this code. Like, we can run this code particular, copy this and run this on your own. So you will be able to see. And then if you see pickle dumps it into this format. This is a binary format. So you won't be able to read it, but this is how it will look like. You have seen some binary objects. So this is how it is. So it's B, and then there is a starting point of it, and then there are all hex numbers. Okay, got it? Like little more information.
Yeah, I got it. Yeah, thank you.
So I can post this link into our chat so that you can later, go through. This is a very good blog. Let me put this into the. Yeah, I think somebody also, wrote that pickling saved our time. No need to build the model. Yeah, that's absolutely right. So you can read this particular thing. This will tell you more detail about pickle, what all things are there. But this is again only a basic thing. We need to look at some different file formats as well. So as we see different demos, we'll be looking at different. So right now we are only dealing with the random forest regressor. That's only one parameter, one model, algorithm. There are multiple algorithms which we can look, and they have a different file format. So, but the ideology is the same. So we need to focus on the ideology right now. Okay. So once our file format is there, we need to save it into a bucket, and then we have a serving container. So how this will be used now? You might be understanding, like, we have a model now, but what about this model? Like, how do you know serve the kind of predictions, like, the users can hit this. So let's see. Now we have a model binary. So what is the next step? Okay, next step is to deploy an endpoint. Can someone help me with what is an endpoint, and basically your idea about endpoint and deployment, if you have any idea? If you don't have, we can start from scratch. Anyone quickly wants to jump in, and it can be right, wrong. We don't have a judgment here. We just want to check what is your knowledge and where we are going. Okay. Anyone wants to comment?
We'll
So
start from
endpoint,
Endpoint. Yeah, endpoint
endpoint
is something like
product.
URL or something, or point where you can access it from external.
Exactly. I think others also commented something, Sagar, right? You are right, Sagar. Endpoint is nothing but a URL where you can hit and get some output when you give some input.
So
Atul?
endpoint for me is like when we give some input inside a website, it will give
Mhm.
prediction like output number. It can be an image
Perfect.
and it can be any prediction based on the input that we give inside that URL web page.
Exactly. You are very right. So that's the exactly called what is the endpoint. Basically, you have a so behind the endpoint there will be some application, the Flask, Django, or some application we are hitting it. Okay. So now our model will be now packaged as a application endpoint. So this is an application in DevOps. Also, you might have like heard about this particular thing. But in ML front, we are having certain model as like there will be certain parameters you will be getting as an input, and there will be certain output parameters that you will be giving out. So there can be single parameter or multiple. It's like we can talk about single or multiple parameters. It's not limited to single. But the endpoint is very correct, like a URL. You have some certain input values, certain output values. Like, let's learn about what is a deployment of an endpoint now. So but for this thing, what you will need, you know like what you will need now, let's consider. Now we are clear, all of us are clear, like what is the endpoint. But for this, how we will get arrive on this particular endpoint? So for this, we'll need certain things like infrastructure. Like, there is a particular infrastructure that will come into place. So let's say we have an infrastructure. I am saying infra. What else? Like, what do you need? Can anyone say? Yeah, please, if you have any idea. Just think about it. If you are having a normal, whatever like web deployment you have done, if you have any experience in DevOps, just try to think like we are talking about, version, different data, model, code, and whatever. If you have any, it can be right, wrong, no problem. We just want to learn together.
For
Anyone?
services, we require services, we require binaries.
Okay, so you mentioned binaries, right? Services or binaries, I think. Exactly. That's right. So binaries, can we call, like, just for not having confusion, we can say a model. So there are some model values, model binaries, and there are some different uh, you know configs, configs. There are some there are some features, or maybe that will come under configs. We can call, like, configs and basically models. There are two things. Anything else you remember, like, where that can come under binaries? Like, so there can be multiple things actually in the binaries. So configs files are also one of the things. Model is one of the thing. In our things, we have features also written. So features are also written as a part of binaries. Okay. So if you say whatever you want to recreate or reuse, okay, say in your code, you need to use this in a binaries. Binaries are nothing but what we have persisted objects, features, configurations, or maybe like pre-processing. Some thresholds are there. You don't need to worry about all this. Like this is again, you can some of them call threshold under configs. Some of them this also called under configs. So depending upon people, they'll call different things. But you don't need to just. I am saying like multiple things are there. So if you come across, you don't need to like worry about okay, we didn't hear about this thing. It's something different. On a broader level, these are nothing but what is this? Like this is a on a broader level, this is nothing but our persisted objects. So these are our persisted objects. Basically, we are putting this in the memory and saving this forever until unless we want them. Okay, infra is one part, model is another part. What else? What else? We are missing some pieces. Anyone wants to comment? So do we need a code? There is some code, but code, is it a standalone code? We need a package code. What is a package code? Anyone else have any idea like package code? What is a code package?
What is zip file or word file?
Sorry, can you please come back? Oh, yeah, I did not hear it properly.
Some kind of war file or zip file.
Um, zip file or word file. So
War file.
So package code is like inside a GitHub, we save all the code, right? Configuration, bin, and everything. Is that a package code including HTML files and everything? The whole package inside like a GitHub.
not really, I think. So let's
So
look at the package. What is a package? So package is nothing but it is having all amount of informations. Okay. So package is nothing but it will. So it's a independent unit of work. So basically, if I save the instructions, okay, you want to deploy this particular independent unit of work. So like it's having everything that is required. Something like if you see like we do right pip install. Have you ever done like pip install something like
yes,
OpenCV,
installing
Python?
all the libraries. Installing all libraries will require pip install.
Yeah, yeah. So what happens in the pip install? Do you ever you ever like thought about it? What happens in the pip? So what is this py? So
Yeah,
this is nothing but
basically,
Python
yeah,
package installer.
yeah. So
yeah,
it's a Python contains a number of libraries, right? If you want to use any specific libraries, explicitly you have to install it. And so let's say I want to use NumPy. So then you can use install NumPy like that.
correct, right. But have you ever thought like how is this working? Like how what does happen when you do pip install matplotlib? Have you ever
From
heard
the
about?
from the website, it will download all the code, complete
Yeah,
code
yeah,
related to that library. Like
correct,
it's a
correct.
separate software, individual software.
Yeah, right. But this is a storing at some physical location like in a static file. So in this we have background called as wheel file, WHL. huh? So where we were, yeah. So this is a pack. So this is one sort of format of a package code. So you have our code, like it's packaged in a way like if you on your machine, like the package thing is like if you on your machine run something like pip install. That is a one format of running a package. So you run a package here. So package is not nothing but a bundled information. Like it's having everything that you have to only have to run a command that will figure out everything that is required. So this package is having all the required, and this is stored usually in a .whl format. So wheel. If you want to, download some wheel, so it will say, if you just Google it out, downloaded files. If you see, right, this one, build distributions. So these are nothing but a distribution. So have you ever heard about distributions? Any one of you? I think somebody said zip also. It also work. It's a tar.gz. That's usually work in a Linux environment. But this is wheel is worked in any, like a Windows, Linux, or any system. It works. Have you ever heard about this? Anyone? Like you guys have dealt about?
No, no, this is the first time.
Okay, okay, fair, fair. No worries.
Yeah, I
So
see that basically. Yeah, whenever you install pip install, that particular library, let's say you're running some cluster, so those libraries will be installed under that cluster. So in while installing, we will see that WHL file, we will see in that execution actually.
correct, correct, exactly right. You are right. So every package happens in this way only. Like if you are also want to create on your own package, you will have to create a wheel distribution file, and then for multiple different processors, AMD, in Linux, if you have different processor, ARM, you will have to create the entire wheel files for the templates. Okay, so that's why we want to have this. So this is a download. Like if you are not sure and you want to, like, you don't have internet or something of that kind, you can use this one also, distributions built. Okay, you can just go into detail and see which processor you have, like, because this pip install matplot, this will use entire things on its own. Like, it will check which distribution to install based on your operating system, based on your Python environment, and it will do the things. Like, that is the work of a pip. Okay, but we just want to see it. So this is very similar. So package code, but now we are getting higher than this. We are now creating containers. So containers are also one of the package code. Why? Can someone say, like, what is container and why we can call a container as a package code? Has someone worked in Docker containers here? Any idea about Docker containers here?
Yes.
Okay. Anyone else, like others have not worked on Docker container, I assume.
The Docker containers are more or less like, the memory containers. It has its own libraries, but minimum libraries in order to run the OS. So, and if you want to deploy something, then you have to deploy it as a package.
Correct.
As of me, I'm not sure about the complete DevOps. Like I'm new. I'm only involved in data science and analysis. But this
Mm-hmm.
container side is a bit new for me.
Okay, no
Yeah,
worries. Yeah,
yeah, yeah. No, yeah, let me tell you, Bhavesh, like in my own of when like what Docker container basically, let's say it's kind of image. Let's say for example you're in Databricks 9.5 version. If you are going to upgrade your version, so your image also should update. So you are controlling your infra activities through your Docker image basically. So your image attaching to your cluster, whatever cluster you are using, you can say.
correct, correct, exactly. So in this same environment, we'll do the same thing. We'll prepare the containers. We'll use these containers to control our system, like as you mentioned, versions of the library or whatever. Like, so nothing but we'll use this on infra. So which is our infra here? Our infra will be hosted by Kubernetes, or maybe like it's happening on Kubernetes.
I want to add something here, especially for containers. Maybe it's very layman's language. Previously, we used to have the virtual machine. For example, if you want to deploy the same application on multiple machines, right? So we used to have the virtual machines, but with the Dockers, that virtual machine and all this kind of stuff has been gone. So one container will be acting as more or less like a one particular virtual machine. So you can deploy the same application into multiple containers. So it's like the same application is getting deployed into multiple machines. You can have different URLs and the stuff like this. So that's the basic concept of Dockers. Instead of having virtual machines, have the Dockers just like your memory containers and be acting as the independent machine, but in memory.
Exactly, exactly right. Yeah, I think that summarizes very well. So yeah, this is the same, thing. Like we need to package into an image, like container image, or maybe like a whatever you want to call it. So this is an image. It's having all the information, the code, the config. So this is having a model binary, or maybe it can call the model binary. Model binary is a pretty heavy object. Okay, so you might not load it into a container. So usually model binary can go into GBs as well. Right now we are seeing only in MBs, but this can go like, big models are there, deep learning models, neural network, they'll go in GBs. Imagine like a chat GPT model, so massive. It's a billion parameters. So for that it will be into multiple GB, or sometime it can be into terabyte also, like, few terabyte. So that requires a very big machines also. So for this you won't download it every time into your container. You can stream the model binary, or maybe you can call it runtime from these all things are there, but these all are required, like information in an image. So everything will be encoded into a Docker image, of which we'll be creating a container. What is a container? It is a live instance of this image. If we say like container, it's a live instance of this image. Okay, we call it as a Docker image, and you know Docker image containers is in live instance of this image, which we call. Okay. Now what we are doing is, what this live instance, the container, it will be having some endpoint, right? It will be having some URL. So again, this will be on our endpoint. So if you see, everything is connected to our endpoint. Like these are all like nothing but a blocks, package code, model binaries will sit into this, infra will be linked into this. So everything is managed now here. Okay, so you are getting some details of how an endpoint is operating, or maybe what are the details of it. So we'll look at this everything. Okay, so far it's clear in theory. Is it fine? Like we can move ahead now. I think we have got the required components, everything we have discussed, and you guys also have a fair idea, like right now, I think. Okay, can we go ahead? Can someone tell me like if it is good, not good? We have any questions? Hello? Yeah,
Yeah,
able to hear
yeah,
me?
yeah.
Yeah,
Go ahead.
cool. All good, right? We can go ahead, right? Okay. So let's say we are having our endpoint. Where we'll see the endpoint here? Anybody else has any idea, like, where we can see our endpoint here? We had seen this one thing, right? Earlier as well, like deployment of our endpoint and how we'll use this. So if you are seeing this one, this model is deployed. This is our one of the regression model. This is the same model which we are talking about right now. If you go into the version detail, this will have all the configurations. Like there will be one container image. Okay. So we talk about this one. There should be a package code, a container. So this is our image. sklearn CPU. Why we are using sklearn? Somebody can help me. Like these are a pre-built image, so which we can see. So there are two things. One is a pre-built, one is a custom. So pre-built is nothing but you have already built this image has been built and optimized by Google for you. Like you don't have to work from scratch. Okay. So Google has given this container to you and mentioned, okay, if you have any sklearn model for that matter, and if you are using 1.2 version, so you can use this container. Okay. So we had using this. There was one page which we have seen, right? I think let me check this. So yeah, here it is. Like so, this is we are coming on this page. So everything is like listed here on this page. So you can just I'll copy paste and use the link here. Pre-built containers. So pre-built containers for predictions and explanation. So explanation we have not seen here. So far we have only seen with prediction. So let's stick with that. So Vertex AI provides Docker containers that you can use your pre-built containers for serving the predictions and explanations. Okay. And these containers are organized by the ML framework. So basically how you will have distributions is a framework. So basically, and this provide HTTP prediction servers. So as we mentioned, we need a servers, prediction servers. So prediction servers, nothing but like, have you ever worked with any server like creating your own servers or maybe like any API? Has anyone worked?
Yeah, I worked on it. Yeah.
Okay, great. Others, I assume like you have not worked on any server or API building.
Yes, I have not worked any of those. I only work with the desktop application. We can create a desktop HTML file so it can take the pickle file and it will give the prediction.
Okay, so you have worked with the desktop application using a pickle file. That's what you are saying?
Yes, yes. Only HTML model in on the system, not in premises, on premises. It's in the system.
Okay, okay, understood. Yeah, no worries. I think we'll look at it in a detail. Don't worry. Let's see. So let's say what is a prediction service. So in the prediction server there will be an entry point. Okay. So the way we are talking in a Docker file. So Docker file is nothing but you will having a certain image, you will have certain configurations, you will have certain commands. So the servers must listen on 0000 port. Basically, 00 is a IP which is listening to any particular IP and a port. Like there will be some port number, say like 8000, or maybe some some different number like port which you have no. So if you don't know about this, it's fine. We'll read this or maybe like talk it into a separate session. But right now we are not going very detailed into this. Like what is a HTTP server. So you can even Google it like this what is a HTTP server and what you are doing it. You will able to understand. So for keeping the class limited, we are not going very detailed. But yeah, if you have any questions, you can discuss offline as well, and I can guide you more. But for a higher level, for now, what we require, HTTP server is nothing but it will be having a container. In our case, it will be a container. It will be having all the different informations and the commands that you are using to run, and then there will be certain instructions in an entry point. Basically, we'll start the server with an entry point, and there will be, as someone mentioned that they are using a pickle and using a HTML file. Similar, you will be loading this model into a machine, and then you will be keeping it ready for prediction. Okay. So in our case, this model, this is sklearn latest 1.2 CPU that we are using, and we are having model path, and then we are having model upload. Okay. Then we are uploading it into a registry with the artifact URI of the model. So there are two things going into this. So there is a serving container, like we saw here. Two things: serving container, package code, and infra. Like these things are there. Okay. So amongst this, like this is a container. and this is the model URI. So into this package code, we have a container as well. So if we have seen this, right? Live instance, containers, we have seen this. So this is going in here, model is going in here, and infra is coming from here. Okay. So what we are worrying about, two things, in artifact URI and container, these things. And what about infra? This is the third thing here. Model.deploy and what kind of infra. So we are mentioning everything here. So now your model is ready for the deployment by having all of these three things. Okay. Once you have all these three things, your model will be live. And how will you test the models? There is some function which we have written. Like, it is using the particular thing. And then if you see here, then we are appending it into. Uh, so this is our endpoint. I think let me see if any endpoint is live. We can see when if endpoint is live, it's saying this is deployed. Actually, we don't need to keep the endpoint live until unless you have some particular usage. Okay, so this is active. Okay, so this is active. That means our endpoint is ready. We can hit this particular thing. Let's copy the endpoint ID. Okay, this is our endpoint ID. This is our project ID. This is our endpoint ID going into AI platform endpoint for invocation. Okay, and what we'll do is write the inputs now. Let's quickly see what is the input here. Basically, let's see df. So this is our data frame. Okay, so this is 20 records which we have taken, and this is all the input variables that we have given. This is nothing but in the x and y. This is x. Okay, which we have built. So this is some validation dataset or testing dataset we have created for just testing the model. Okay, out of this, we want to just use one particular record. Okay, clear? So what we'll do is instances, we'll create this. So what we are doing is df values to list. Basically, what this does is converts a particular thing into arrays. So the endpoint wants in particular way. So endpoint wants the things in a particular way, like this, no, the way we had seen. So endpoint requires input also in the same thing. It will give the output also in the similar format. Like this will be 2, 0, 5 based on the columns. If you see, we have already listed here. Let's see df. Okay. So this is 2 is corresponding to the season. Year is 0. Okay. Year is 0. Month is 5. If you see here, holiday, then we have a 0. Similarly, 0, 1, whatever this is there. Each value corresponding to a single column, and this corresponding to a single row. This entire one array. Then similar, this is the second record. Okay. Are we clear so far? How we are encoding this model information here?
Yes, yes.
Is it
Only
clear?
model takes a particular data structure that for giving exact prediction.
Exactly, right. We need to put it into a certain data structure. Otherwise, the model will not know, what you are giving. So, these are all, we were seeing long floating point numbers here. You see, like this one. This is not creating actually much value, but we are keeping it. So this is for the precision, like precision we keep. Like there should not be much error. If you round it off, the slightly error will be introduced. Like you will consider slightly different. So in machine learning, there are some. So you need to care about the precision of the numbers also. That's why we were doing. So if you want to lose some precision, like some performance here and there, but you want to increase the performance of it, it will be using you will be losing some performance, but you will be increasing your time. So there's a trade-off you need to manage. So let's say length of the instances, let's say it's 20. Okay. So what if like I want to only use one instances? Like I want to use the one. Okay. I'll get a one. Like this is the first zeroth row will be the first row. Let's go here and like put it now instead of instances, the entire 20 things we'll put only one. Okay. Okay. Let's put and see whether we are giving predictions. Okay, it's saying something. Okay. Okay, got it. So it says a 500 error. You see like how we are getting this error? So it's expected 2D array, we got 1D error. Can someone mention why we got this error? Do you know? Like why we got this error? We are passing this one. Okay. This is which kind of array?
It's 1D array.
Correct,
Okay.
correct. And the required input is 2D array. What can I do? But we are passing earlier. Earlier we were passing this one. This is which kind of array?
2D array, 2D array.
Correct.
Array.
So
Yeah.
we need a format like this one. That's why we are getting a issue. So either if you want, you can package this particular input into a 2D array, or like you can what you can do is you can call the entire thing like which we have a 20 records. Okay. So 20 records will be gone input and then 20 outputs will be there. Let's see like remove this one. Okay, we got the 20 output. So if you see like in a blink of it, it create me 20 predictions. And if I want, I can create one like and it was giving me model ID, version, model resource name, explanation, whatever the parameters are output. So this is our prediction output out of our endpoint. So our endpoint is hit like this. Sorry, close this. It's taking too much time. So if you see here, this is our regression endpoint. This is the other one. It's still loading. Yeah. So if you see like this one is the active one which we have, and it is hitting like we are getting this. So in the end, if you see like there is some graph also which is a real time. So if it is seeing prediction per second, how much time we are taking? It's a 0.02 of a second. 0.02 per second. Like how many we can do per predictions per second? It's like 0.02 which we are consuming depending upon this. And the percentage error is there. No prediction error is there. So request per second, how many requests are we handling? So for one particular request, we are taking 0.10, 0.010 of a second. That much. You know. See, these are the number of records. So this can vary, depending upon how much you input, what is the thing. And right now we are using only one machine. So if you have to increase or you have to auto scale, what you have to do is you have to use the number of instances as more. Like you know the way we were and inputting this minimum replica count, maximum replica count. So this is nothing but where you have to control. So you say 1 and you say 10 here. So then minimum will be 1 and maximum will be 10. So depending upon when you scale up, it will be going automatically. When you have high number of predictions input, you will be scaling the thing. The replicas will be more. That's where that's where our container comes in. That is where our container gets used. So we are creating our endpoint from the same container, this one like a package code. So here it is, in our case we are using a pre-built container, but the model is ours. you know the API that we are writing is there, like they have written this particular pre-built containers. Okay, but why we are able to do this? Because we are using certain model. So if you have certain models like sklearn, pytorch, or whatever, you will have this particular containers. So for TensorFlow, you have these all containers. If you are using GPU, you have a GPU container. Now, if you are using CPU, you have a CPU container. So it's your job to find which is the appropriate container for your particular model. Okay. And let's say like, you are not able to find like a runtime, like a good runtime or maybe good uh, particular serving container. So what is the next step? We have to create our own like custom container. So most of the time you will find a pre-built one, but multiple times you will not find a pre-built which is not serving your project requirement or something of that kind. Here you create your own containers. You write the HTTP server, write the entry point, entire instructions, whatever is there. You check the things. You have the health check. But if you use the pre-built container, everything will be done for you. Okay. So you need to handle the prediction request, a status code also, everything you need to follow this. So we'll see the custom container as well. In one of the class, we'll see the custom container, like because we need to learn about, right? Every time it will be not that we are using a pre-built container only. Pre-built container we have already seen. Like we are using sklearn. If you go Control F, find sklearn. Here it is. Which one you are using? We are using this one, the second one, 1.2 version, CPU only machine, like CPU only US Docker, Cortex AI, sklearn, CPU. This is what we have learned. So this is the latest one. We see like a 1.3. Our model is slightly older. We are using this one. Okay. We are clear, right? How we are doing the serving now. Once you have this ready, you will have everything in the into an endpoint, and like we have used the endpoint. We see this is how you use the endpoint. Testing the endpoint using Python SDK. So imagine like so even this can be a curl request. So there is a different way, If you just go, I think I'm not sure why it is taking too long. Yeah. But you will see a sample request. So this is a REST API. So this is a curl request that you can put. If you have parameters in a certain way, like instances in a certain way, you can use this particular thing. What we have used is second one. This one. Okay. This we have used one using a Python SDK. Okay. So this is a simple way. So Python SDK means any code that is using Python will be able to query this particular model or maybe like produce the predictions. If you want, you can also try this particular thing on your machine. Like so it will work equally well on your machine if you have only this line of code, right? And you need like these instances. So these instances you need a project ID, location, everything. And the same code will work on your machine as well. Okay.
So one question is that you have the data, you're passing that particular data through the REST or through the JSON. It's doing some kind of processing, and after that, it's doing some kind of prediction. What kind of prediction it is?
What kind of prediction you made?
Yeah.
So prediction is
Mm,
so is it a question like what is the problem statement or what data this is like what?
yeah, yeah, something. What is it doing with this kind of data?
Yeah. So I think in the first few sessions we are using the same data set.
Yeah.
So this is a bike prediction, like bike rentals prediction. So we need to see how much is the count. Let's say example
Mm-hmm.
for a given year, season, month, and a
Hmm.
particular hour. Given that it's a holiday, not holiday, weekday, working day, we are predicting how many bikes will be used on that particular hour.
Okay.
This is the
Yeah,
count.
depending. Yeah, it will see the pattern, and depending on the pattern, it will give the prediction.
Exactly. Yes. Yeah, that's right. So we are using a regression. Okay. I think yes. So we dealt a little deeper into serving containers and this today. So, but yeah, still we are going very slow right now. We need to look at the entire pipeline, this the entire steps which we saw, we need to automate this. Like actually this was the goal, but yeah, as we are going little slow, we are, talking each and everything in detail. So based on the request that we got. But anyway, ways, like if you have any questions or so far, we can, have that questions right now. Otherwise, we can close the session and tomorrow we'll look at the MLOps level on automation, and then we'll look how we are creating, all of these components, maybe each and every container. So I think we need at least 1 or 2 hours more on this one.
Okay, thank you, Bhavesh.
Yeah, Bhavesh,
Thank
can you
you.
share that book till perhaps level 0 at least, so that we can try from our end?
Yeah, yeah, absolutely, absolutely. So, yeah, so what we are going to do is, we are going to create a Google Drive. Like, they have asked us to create a Google Drive and share with you as well. And what we'll do is share all the resources, materials, like any reading materials that I have, PDF or maybe, anything, or maybe some links also I'll create, so that I'll do it today itself. I had to do that yesterday, but I was out yesterday, so yeah, I couldn't do that. But yeah, I'll share it today itself, and you will get that every link, whatever we are using so far, and we'll maintain all the documentation there. So you can run it on your own, like use your GCP trial account, free trial account, use
Yeah,
it,
yeah,
or
yeah.
that will create a help for you. Yeah. Okay. Thanks a lot. I'll share with you guys. You will get it very soon. Okay. Thank you guys.
Thank you, Bhavesh. Bye.